This is a T6 probability question written by CCEA for January 2017. While in newsagents, the probability that Ed buys a newspaper is 0.8. The probability that Ed buys a newspaper is 0.8. In some newsagents, the probability that Ed independently buys a magazine is 0.3. Magazine is 0.3. That's for newspaper. Work out the probability that Ed buys at least a newspaper or a magazine in this same newsagents. He could have bought a newspaper, or he could have bought a magazine, or he could have bought both a newspaper and a magazine. So could either have bought just a newspaper or just a magazine or both. Probability of not buying a newspaper, Ed buys a newspaper not is 0.2, and the probability that Ed buys a magazine not is 0.7, because 0.8 and 0.2 add to make 1, and 0.3 and 0.7 add to make 1. The probability of just a newspaper is newspaper and not magazine, which is this one. Or means you'll add. For just a magazine is magazine and not newspaper. Or, which means we have to add again, the probability of a newspaper being bought and a magazine being bought. From here on in, I'll use notation N for newspaper and M for magazine. So the probability that he buys at least a newspaper or a magazine is newspaper and not magazine, or magazine and not newspaper, or newspaper and magazine. Probability of buying a newspaper was 0.8. Probability of not buying a magazine is 0.7. Or means plus. Probability of a magazine being bought is 0.3 times the probability of a newspaper not being bought is 0.2. Or means plus. Probability of a newspaper being bought is 0.8 and means multiply. A magazine being bought is 0.3. So I have 0.56 plus 0.06 plus 0.24. Not 0.24 plus 0.06 is 0.30, and 0.56 plus 0.3 is 0.86. So this is the probability that he buys at least a newspaper or a magazine. Now, this seems like a lot of effort for just the 3 marks that are allocated to the question. If you look carefully, you notice that the only thing that has not been considered was the probability of not buying either. So the probability of not buying a magazine and not buying a newspaper was not considered. So if I got that probability of not buying a magazine, which is 0.7, and not buying a newspaper, which is 0.2, and the probability of not buying these becomes out as 0.14. All the other possibilities were considered. And all of the other possibilities, plus that one possibility, should all add up to 1. Therefore, if I did 1 minus the probability of not buying a magazine and not buying a newspaper, I would get the probability of buying at least a newspaper or a magazine. And notice how my answer is the same for a lot less working. This is a more time efficient solution to this question.